Okay, we're rationalizing the denominator in this video, and we're still dealing with surds. Okay, so you know in a fraction we have the denominator there at the bottom. And because surds are irrational numbers, it makes sense to have a rational number on the bottom a lot of the time. So sometimes we need to use this skill called rationalizing the denominator. It basically converts the denominator from a surd to a rational number. I.e. no surd. So the general pattern involves multiplying by 1. Now if we multiply something by 1, there's no change in the value. Okay, we can do that. And how do we multiply a fraction by 1? Well, we have to have the same thing on the top as the bottom. Doesn't matter what it is. Well, it can't be 0, but apart from 0, it needs to be the same number, same value. So that's equal to 1, isn't it? So that's what we're going to do. We're going to times a surd by a fraction. The general pattern is like this. So if we have that, there is an example of a surd in fractional form, and the denominator is irrational, and we need to rationalize it. So you can see what we do. This is the key step over here. We've got the surd written again there, and the key step is multiplying by 1. That equals 1 because we've got the same thing over itself. Did you also notice that what you choose for A is based on what's on the denominator of the given surd? So the rest of it's just multiplying fractions, which you should know how to do if you're watching this video. We multiply the numerators together, we multiply the denominators together. So x times root y is x root y, and root y times root y is, well, you should know that root y times root y is root y squared, and that gives y. And so that's where that denominator comes from, and it's no longer a surd. It's rational now. Let's look at an example. We've got 2 over root 3. Okay, so we need to multiply that by 1. We're going to choose root 3, which is on the denominator, times it by root 3 over root 3. The numerator is going to be 2 times root 3, or 2 root 3. The bottom is going to be root 3 squared, which is just 3. So that's rationalized now. Next example, we have 2 root 6 over 5 root 2. Now remember, we're just looking at the surd on the bottom. So we will have 2 root 6 over 5 root 2. Now that root 2 I'm just drawing in now, that's our key. So root 2, root 2. Let's draw that 5 in properly. Multiply through. On the numerator we have 2 times root 6 times root 2. We have 5 times root 2 times root 2. And we have 2 root 12 on the top, and 5 times 2 on the bottom. 2's cancel. We have root 12 over 5. Now, most marks for getting there, but not all of them, because the really keen people understand that root 12 can be split up and simplified, because we have square root of 4 times the square root of 3. 5's okay, leave 5 alone. So that's a square root of 4 is 2 root 3 over 5. Third and final example here. So we have 1 minus root 3 over root 3, and what we're going to do is multiply that by root 3 over root 3. You can see the root 3 there. So we have we're going to multiply by root 3, I should say. So multiply by root 3, top and bottom, numerator and denominator. Okay, so we have now on the numerator, in case you can't see it, what we really have is 1 minus root 3 all times by root 3. Or you could say root 3 out the front times 1 minus root 3. Just change the order around because it's multiplication, and we're going to use the distributive rule there, which you've done before. So that's going to be root 3 minus root 3 squared. On the bottom we've got root 3 squared. Now you cannot cancel that without cancelling that, so don't cancel yet, simplify. So root 3 squared is 3, and on the bottom root 3 squared is 3, and there's our answer. Surely that's the easiest thing you've ever seen in your life.